Hoda?
Yes. Somebody has to check and tell me.
Ada, I'm doing that. Don't worry. I think duplicate entry. நீங்களும் நானும் ரெண்டு பேரும் ஒரே சமயத்துல போட்டதுனால it is given a error.
Possible, sir.
Yes, streaming. Can you see?
I'm not seeing streaming here.
No, can you see my thumbnail?
Yes.
Streaming. Can you see?
Yes, sir.
Okay.
Copies also.
Yeah, there are 10-second delay.
Yes.
So don't worry about it.
Thank you, Gopi. இனிமே நான் அனுப்பிச்சிருக்கிற மெசேஜை நம்ம ஒரு 5 minutes கேப்ல வந்து ஜஸ்ட் chat boxல Zoomல போடுறதுக்காக I had sent it. இதுல தான் polls run பண்றோம் so that people who are both on YouTube as well as Zoom can take the polls.
I'll not be able to do that because I'll be going full screen now for the YouTube. I'll be closing the chat box.
Okay, I copied it.
Okay.
And I kept it. Yeah, sure. JJB sir comes with it.
No. Come. Hello, Rizwana. Meet my husband.
நல்லா இருக்கேன் சார், நீங்க எப்படி இருக்கீங்க?
Fine. அப்போ 19ல SN மீட்டிங்ல பார்த்தது.
ஆமா சார்.
How's things?
Things are all fine சார்.
சங்கரன் கோயில் போனீங்களா?
சங்கரன் கோயில் ஆமா இப்பதான் போயிட்டு வந்தேன் சார். லாக்டவுன் எடுத்த உடனே போயிட்டு வந்தேன்.
நாங்க கோயிலுக்கு போவோம்.
ஓ சங்கரன் கோயிலுக்கு.
At your native place, if I'm not wrong.
ஆமா சார்.
How's things? But I heard you are moving out to வேற போறீங்கன்னு சொல்லிட்டு profession.
ஆமா சார், I'm going to the University of the West Indies sir.
எங்க which place?
West Indiesல Trinidad and Tobago ன்னு ஒரு
See, only thing I know about West Indies is cricket.
எனக்கு அவ்வளவுதான் சார் தெரியும், போனாதான் அங்க என்ன இருக்குன்னு தெரியும்.
I heard it's a very good country. I had a patient from Tanjore. Like he was telling a few other so systematic. நான் கூட ஒரு apprehension போனேன். ஒரு business ஆரம்பிக்கிறதுக்கு he had some paperwork done. ரொம்ப பியூட்டிஃபுல்லா முடிஞ்சது. Not like we think like a lot of blacks அந்த மாதிரி ஒரு ஆப்பிரிக்கா ஆங்கிள் திங்க் பண்ணுவோம். He said it is pretty well developed. More of a tourism spot also.
ஆமா சார். It's one of the richest countries in the world.
It's very famous for the beaches. Very the blue Caribbean islands. It's more that.
Correct sir.
I never been there. Maybe US ke paal போகும்போது வரணும். It's almost very close to US.
வாங்க சார். அட்லீஸ்ட் ஒரு 3 வருஷத்துக்கு அங்க இருப்பேன் வாங்க.
நாங்க இந்த ACRS மீட்டிங் போவோம் பட் never travel down
to them.
Florida. தம்பி சான் பிரான்சிஸ்கோல இருக்கான். அங்கிட்ட வெஸ்ட் ஈஸ்ட் போயிருக்கோம்.
ஓகே.
கீழ வரணும். we'll have to come.
வாங்க சார், அப்படியே வெனிசுலா, அப்படியே மெக்சிகோ, சவுத் அமெரிக்கா சைடு வந்துட்டீங்கன்னா வந்துடலாம்.
Santiago ஒரு தடவை போனோம், மெக்சிகோ border. So nice place, like.
Yeah, it's very beautiful.
Thambi used to talk a lot about the place. நிறைய அந்த recreation, scuba diving, நிறைய என்னமோ அந்த boat cruise.
ஆமா சார், நான் கூட கொஞ்சம் வேலையை குறைச்சிட்டு அந்த மாதிரி வேலை நிறைய பண்ணலான்ற விஷயத்துக்கு தான் போறேன்.
When after some years probably we can afford, yes, we need to retire.
நான் கொஞ்சம் ஏர்லியாவே ரிட்டையர் ஆகலாமான்ற பிளான்ல தான் போறேன்.
ஓவரா படிக்க கூடாதுன்றது. நாளா கொஞ்சம் பேலன்ஸா இருந்துக்குவேன். அதனால சர்ஜரி, அகாடமிக்ஸ் எல்லாமே. So you don't get so yeah, good. Like I keep telling about you to all my team. Such a knowledgeable person in the orthopedic area, pediatric ophthalmology.
Thank you, sir.
There are a lot of people who are just very young from schooling. நான் அரவிந்த்ல இருக்கும்போது 80, 90, 93, 95 நான் ஃபெலோஷிப் பண்ணும்போதெல்லாம் அப்பெல்லாம் ஆப்டோமெட்ரி இப்படிலாம் கிடையாது இல்லையா. அப்போ அங்க உள்ள இந்த மாதிரி +2 கேர்ள்ஸ் தான் அங்க அரவிந்த்ல இருந்தே ரொம்ப நாள் இருந்தவங்க. அப்படியே தேவர் establish them into the senior optical orthoptists or whatever it is. We used to learn squint from them. In fact, they'll be the one who will be teaching us எப்படி மெஷர் பண்ணணும் எல்லா எதுவுமே. ஸோ அதனால இட்ஸ் a very nice thing to happen. Good. Let get into program start. Okay.
Thank you, sir. Thanks.
Yeah, all the best. We'll visit you this.
Yes, sir.
நல்லா இருந்துச்சு.
Okay, so as it is 4:30, we will start the program, and we are live on YouTube as well. So a warm welcome to all our delegates who joined from all across the state and also country for this I Teach webinar on Scare of Statistics No More. So this welcome address that I'm going to give is more of my experience sharing. So if you had asked me 15 years before, if I'm not 15 years, I think it's too long, maybe 11 years before, if you are scared of statistics, Rizwana, I would have just told, yeah, very much, because I was so scared of numbers and maths and statistics. And as all of us know, when we like a subject, it's more because of the teacher that we like the subject. And then we were so blessed at the Elite School of Optometry and Shankar Nethralaya to have teachers like Dr. M.B. Sudarshanam, who is going to be with us today. So when Dr. M.B. Sudarshanam was introduced as our research methodology teacher as part of our master's program, I should say that the love for statistics for many of us grew to an extent that some of us, in fact, became teachers of biostatistics and research methodology. So I think this will tell you like how you can move from a place of fear where you are like, no, I just don't want to handle statistics at all. You're so crippled with that fear. then you move to a state where you are able to run your own statistics, you are able to understand research papers, you're able to establish yourself in the scientific industry. I think that is what miraculous teachers like Dr. MBS can do. So with that introduction, I'm just going to give the stage over to Mr. JJB sir to introduce our speaker for the day, Dr. MBS Darshan. Over to you, JJB sir.
Thank you, Rizwana. Hope you people able to hear me. Actually, Rizwana done almost half of the introduction. Dr. M.B. Sudarshanam, fondly called by us or by most of his students as Dr. MBS. We know each other little more than 10 years. I met him somewhere around 2008. First time at ESO, that time he was a visiting faculty and he used to teach systemic diseases. Then he started teaching research methodology and biostatistics. One major contribution to ESO or SN before or after Dr. MBS joined as a faculty. Before that, we used to go to biostatistician to with our data, what to do, what analysis we need to do when the results comes out, what exactly it means by. So all this question we just bombard them with the statistician, and whatever they say we just write and we put it in our paper. We don't know head or tail. But one of the major contribution what he made us is he made all his students to do all the statistical analysis completely. He made us to write the interpretation, and we know what we are writing. So that is the biggest contribution he has done it at ES. So I'm sure end of this program or end of this course, at least most of you could reach to that level. After completing his MPH, he moved to Delhi and he was handling research and monitoring and the evaluation. Currently, very recently, he moved to Finland as a global health director at Scope Impact, Helsinki. Putting it on one simple statement about Dr. MPS is every student dream of having a teacher like you, or other ways to say, you have a very special place in your student's heart. With that word, I will hand over the stage to Dr. MBS and look forward to your session, sir. Thank you. Thanks, Rizwana, for this opportunity.
Thank you, sir. Before Dr. MBS officially takes over, I'm just going to, show you all something which you have to make a note, because this is what we are going to use over the next 45 minutes for understanding your knowledge and for making the session very interactive. So I have typed the website address in there, but I'm just going to show the screen. So this is what you all have to just maybe use your mobile phone or wherever you are. Just type in menti.com and then type this code, okay? 57179398. I'll give you like 2 minutes to do that, because we want to understand the profile of audience who has joined with us today. And because some of you have joined like as teams, like for example, we have a big team from Mahatma Hospital, Trichy, who joined with us today. So, and also there are people live on, like who joined with us on YouTube. So this is the polling website that we are going to use. So menti.com, and use this code. And then I'm just going to start the first polling while Dr. MBS prepares himself for the webinar. So this is also in the chat box on both the YouTube as well as the Zoom chat box. So please make a note of this number and keep logged in, because throughout the session we will use this. Okay. So I'm going to go over to the Menti website as well. And in the meanwhile, MBS sir, you could maybe just give an introduction about yourself, like if you want to.
Let me. Hi everyone. Good evening. So I'm joining from Helsinki. It's afternoon here. It's always a pleasure to talk about statistics, because like everybody, I was also scared of statistics. I'm an alumni of PSG Medical College and then later JIPMA Pondicherry. So I did my MD Community Medicine. That time I used to be very scared of statistics because of the numbers and concepts. Then after finishing my MD, I think I joined. When I came to Chennai, I got an opportunity to teach undergraduate students in Leslie School of Optometry. Then they were looking for somebody who can teach biostatistics. I was a bit, and that is the batch this one I belong to. So I was very scared of teaching biostatistics at that point of time because I could do biostatistics myself, but it was not so easy to teach people. And it was a big batch. I think around, it's more than 15 people, I think. It's a big group of postgraduate students. You have to teach biostatistics. So, fortunately or unfortunately, I think I could really pull it through, but I was not very happy because we still used formulas, we still used numbers and stuff. So when I went to Hopkins, the entire uh, teaching of biostatistics, the way they teach biostatistics was very different, and I was inspired by that. So when I came back, I approached KK and others at ESO. I said I want to teach biostatistics conceptually moving forward, and I think it was really encouraged. And I was teaching there for about 4 years. Then we started doing. Okay, then I had to move to Delhi. So that is at that point of time we started doing a lot of workshops. So we did shorter workshops of 3 days, and this is the first time we are just going to do a bit of a webinar kind of. Usually, I'm a person who is like with a very comfortable with a blackboard and a chalk or a whiteboard and a marker, because that I feel is very important and very crucial in developing concepts, building concepts. Many of the students, some of the students, I could see some of my students have also joined this. Are you able to hear me properly now?
Yeah, it's
Or am
better
I?
now, sir. Yeah, it's
Okay.
better, definitely. Yeah.
Okay, right. Uh, so, so then, so this is the first attempt in this virtual mode to teach biostatistics. I have done a lot of webinars, but this is the first one to like really share some of the concepts of biostatistics. So that is where I'll stop. Maybe should I proceed with my presentation now, or like
Yes,
should
sir.
we wait for another minute?
Yeah,
People.
another minute, I guess, because mm, so I just want to just talk about this menti.com. Request all of you individually to just open this www.menti.com and then use the code that you see on the screen and click the option that best describes you. You could choose up to two options, and then so that we know the profile of our audience who are here with us today. And Dr. MBS, if you just see in, at least it's like a scatter that definitely that you can pick up. We have majority, of course, are optometrists and who are into sorts of UG, PG practicing, and 10% pursuing PhD. So overall, 15% of our audience in here are pursuing some sort of a research, and and we also have people who are into eye care and interested in data and then research. So yeah, so can you please share the code again? So I'm going to type in the chat box. So can you, if you, yeah, Abba, if you can see my screen, that is the code, Abba, like that you have to use on top of the screen. So please just make a note of this so that we will be using polling as Dr. NBS proceeds through his presentation. So we want the session to be as interactive as possible. I put in the chat box again. And so as people keep going, I'm going to uh, leave the stage to Dr. NBS to take over. So I'm going to give you the hosting permission so that, yes, sir, you can go over and start your presentation.
Sure. Just a request. I think it also came up in the instructions. That is, please use the chat functions for any questions you have. You want me to repeat anything, please flag it there. But if you have a burning question you think that I can answer better, so maybe we can reserve it for the end of the presentation. So a presentation normally is planned for about 40 minutes. So it should not take more than 40 minutes, including the quizzes, like the polls in between. But in case if somebody wants explanation again a couple of times, it can spill over up to about 45-50 minutes. So please bear with us for that. So let me just go ahead and share my screen. Okay. You're all able to see
Yes, sir.
my screen now? Right.
Yes.
So let me start with a quote. I think this is a very famous quote for any statistician. Of course, in God we trust, but all others must bring data, especially when you are a researcher. You must bring a lot of data. This also applies for a clinician, I would say, because that it's not about bringing data, it's about using that data available. Most of the clinical practice, if it is done through kind of information available, processed information available, then there is a lot of advantage. One is the outcomes of your clinical practices are better, and when you do it is ethical because that is the latest available thing. In in your field. The third thing is also that you are protected against any kind of legal aspects as well, though that is not the main aspect, but it is ethical, it is professional, as well as it is the best you can give for a better outcome. So having said that, he did this profile poll very much now. I'm going to make some statements on clinical settings and statistics. So for this, I have taken some examples of COVID-19. I'm going to give you a disclaimer. I'm not an ophthalmologist. I'm not an optometrist. So I'm trying to get, so all my examples are towards more generic, so that it is not going to be very specific to your field, but I am sure that you will be able to understand most of the examples, of course. So it should not be a problem for you for understanding them, hopefully. So I'm taking an example of coronavirus because that has been the talk for almost the past
Sir, just
years.
1 second. Can
Yeah.
everybody hear Dr. MBS clearly? Because, sir, I hear from Mahatma that your voice is a little feeble.
A little
Yeah,
more louder will help.
More
it's
louder will help.
clearer when the mic is held close. Yeah.
Okay.
Yes, now it's better. Yeah.
Okay, let me keep it this way. So in case if you are not able to hear, please just unmute and let me know, because otherwise I'll not know that mine is like.
Now voice is quite clear and audible. Thank you.
Okay.
Thank you.
Thank you. So I'm going to take an example of coronavirus because this has been the talk of the entire world since 2019 December. So one of the things which came up is also about BCG and COVID-19. This was much talked about because you still people are talking about it, that when countries which have been given mandatory BCG, the deaths are very less. If you can just look at this graph, if you can't understand the graph, it is very simple that they have divided into three categories. One is with vaccination policy, who had vaccination policy in the past and who never had a vaccination policy. So, and the mortality is very low with countries with universal BCG vaccination policy. What this data says is also that on a country-wide data, it is not at an individual level, it is not even at a group level, it is not like a study which has been done, which is like a BCG coverage rate across the country and the mortality. You don't have individual level data as such. So it's so what happens here is that we are not very sure whether it is applicable to the individual level. So though this evidence is important, but it doesn't clearly prove anything for a clinical practice whether giving another dose of BCG is going to help the population or not. The second question, which I always normally I was facing even when we started vaccine like in January, is whether Covaxin or Covishield. There are several differences whether we can definitely compare this or not. How we are going to like really put forward this kind of information between Covaxin and Covishield to take a clinical decision or help people make a decision. There are several things. For example, Covaxin is a more of a killed kind of a vaccine or a inactivated kind of vaccine, where Covishield is going to be Covishield is a very different kind of vaccine, which is a vector vaccine. So comparing this and putting across the data or evidence for people to really understand. Even now, you cannot really say whether Covaxin has an increased efficacy rather than Covishield, because there are still studies going around with Covishield, which is like with an increased gap. So we can only, at this point, we can only say about what does the data say in comparison, and leave it to individuals to take a decision. Okay, sorry. I don't know, my slide is not moving. Right. Now, there is also worldwide evidence which has been floating across is on the clots which produced by this Covishield. But there is no evidence as such, because clinically as well as statistically, there is not much evidence to prove this association. That's what we would say. These are all examples where there has been evidence, but what has been the implication for a clinical thing? For first one, yes, there is not much of evidence for a clinical level to take a stand on BCG. The second one, between the two vaccines, still we have evidence that both the vaccines have been efficacious, but which vaccine is better, we do not have the evidence. The third one, there is no evidence as such to stop as such one of the vaccines. So let's talk about this. Why is one scared of statistics? I just gave you this example. Statistics say that 1 in 4 people are insane. So take a look at your 3 friends. If all of them are okay, then it's you. Probably you, right? 90% of the people are scared of numbers, I would say. Even here, I'm just trying to make it with a number, but it is true that people are scared of numbers. The next statement I'm going to make is, look at this one. Complex head spinning formulas. The people, once they see complex head spinning formulas, they say, this is not my cup of tea. Confusing names of statistical tests. You say students t-test, paired t-test, unpaired t-test, ANOVA, ANCOVA, chi-square test. Like, you have a multiple number of clinical things to remember. So these are all very confusing for a day-to-day practicing practitioner. And second thing is that statistics are very crucial. Okay, because you also need to know what it actually is covering up. It's not actually what it reveals, what it covers up also. So what I'm just saying is that we do not understand the clinical implication of the statistical significance. We think about people do not understand what will be the clinical implication of a particular study or a particular statistical test. We do not understand, and we also do not correlate whether it is clinically significant when there is something which is statistically significant. So these are the 4 statements. So what I'm going to do is, I'm going to stop share for some time and hand it over to Rizwana for the next poll. Rizwana?
Yeah. So this is just the compilation of people who have answered so far. So if you're on the same screen, just hold on. I'm going to go over to the... So look at the number, look at the statements on the screen, and what would you, okay, what is your agreement for each of the statement? Just, you can move the cursor across, and just click the number that you feel is appropriate for you according to your agreement. Why is statistics so complicated? Okay, so for that question, what is your level of agreement on a scale of 1 to 5, where 1 is disagreeing and 5 is agreeing? So you can, choose the number, and as everybody keeps choosing, we will see the visualization on the screen in here. So for people on YouTube, I put the website and the code in the chat box, and for people on Zoom, and you can, or everybody, you can see even the screen on top where you have the details. So what is your agreement about these statements? So majority, I think, is as of now like not statistically significant, but people are scared of complex head spinning formulae and statistical and the clinical implication of statistical significance, followed by fear of numbers and confusion with statistical tests. So we'll wait for another 30 seconds. So request everybody to sort of share your views. This is completely anonymous polling. The reason why we run this polling is we will not know who has given what answer, and we are not going to sit and analyze this as well. So feel free to completely just enter the answer that you feel is appropriate. So feel free to participate, because that will help us to understand the current level of understanding as well as your thought process, so that our speaker can catch it to your needs. So all of it's closely on the same scale, so everything gets a. Okay, so I'm going to hand it over to. You guys can keep answering, but I'm going to hand it over to Dr. MBS. Yes, sir. So you have to unmute and sir, you are on mute.
No, I have some problem with my screen sharing and unmuting myself. Okay, right. So you able to hear me? So how to make statistics simple? Do I have something like a Harry Potter wand to just make it very simple? No, I do not have. But what we have tried in the past, maybe for past maybe 12 13 years, we have been trying to make it very simple, is that conceptualizing things and also bringing in a lot of clinical examples for people to understand statistics so that they can apply statistics on a daily basis. So this is also one such attempt. So I'm not, if there has been a wide range of expectations from people. Some of them have asked me like, we are very keen in learning some analysis from this webinar. I'm really sorry, this is not a webinar for that, because I cannot cater in an hour about some statistical analysis. It's not possible. But some people wants to understand some basic statistics to interpret some of the papers they read. Yes, possibly you will learn few things from it, but not completely. You might have still some more questions with you. So that is how it is. So with that in mind, let me start with some basic things. What are the types of variable? Variable is something which varies from one person to another. That is variable. It can be your name, it can be age, it can be the gender or sex or occupation. It generally varies from one person to person. So we classify them into two types of variables. One is continuous. That is, you can have continuous numbers. Continuous numbers means you can possibly have decimal places. Whether it is intraocular pressure or blood glucose, possibly you can have decimal places. These are called continuous variables. And other thing is a categorical variable. Categorical variables are like, suppose based on your blood glucose, you divide people into diabetic, non-diabetic, then they become categorical. I mean, based on intraocular pressure and other parameters which we use, you have subjects of glaucoma, without glaucoma kind of. So this type of categorizing people based on some values is called a categorical variable. I'm making it very simple at this point. I'm not going to different scales of measurement and stuff so that people understand it very simply. So is it very clear that what is continuous variable and what is categorical variable? Is there any chat responses?
They say it's clear, sir. Yes, it is.
Clear?
That's what they say.
Okay. Right. Let me move on then. Somehow my screen is like stuck. It takes time. I don't know why.
Yeah, because you are in Finland and it's very cold. It is also a bit lazy.
I think I have to stop share and then start if it doesn't move to the next slide.
Just click on it maybe a little bit forcefully. Sometimes Zoom behaves a bit crazy, sir. Yeah.
Okay. So this is like a hypothetical example. So you know what are the variables now. Okay. Suppose this is a hypothetical example. Many of you would have seen in your own life that you would have gone for a date with somebody, or you would have gone to see a girl or a boy. Okay. So or you would have liked somebody. So what you would have done with them? First is that you would have like really had a conversation to see what are the things which are very common to each other and what are the things which are not so common, how we both agree and how we both disagree. This is what you tend to do with over a period of conversation. Okay, this is what a statistician is also trying to do, and he said that trying to flirt and say that you're 3 standard deviations above the norm to that particular other person. We are not going there, but what we are trying to say here is that whenever you talk about when two people meet, especially when in a thing of like sharing life, what you always try to share is about what are the common things and what are the things which are not common. In the same way, when it comes to data, you try to explain the data or a variable in terms of two things, which is more common, which are the things which is how common the data is and on how diverse the data is. So that is where you explain data. One is on the commonality and how diverse the data is. So this is called as the descriptor statistics. You describe some of your data, describe any of your data or a variable in terms of two things. One is on your central tendency, how close your data is, or how you can summarize your data. What are the common things in your data? That is where you use what is known as a mean, which is a simple average, which everybody knows. Median, which is the middle value, or in terms of percentile, if you want to say it is the 50th percentile. That is nothing but if you have 100 values, what is the middle value? This is also the 50th percentile. The third one, mode, which is the most common value. But again, a word of caution, you cannot use average everywhere. And the cartoon which is there in this is a very typical example. Statistically speaking, the average person has one testicle and one breast. It's not always true. Okay, so you cannot average things across populations which you are not able to, which you are not supposed to average. Again, I want to reiterate one thing. When you describe suppose what are the things when you're meeting a new person, you are trying to see what are things which are common between you and what are the things which are not so common between you. Similarly, when you have a new data, what you tend to do is you see what is common, what is common between all the people who are there in the study, or what is common in the variable you have, and how diverse we are. We saw what is common, so let's move to what is diverse. This is called measures of dispersion, which talks about the diversity of the data. The most common thing which you are using is always a standard deviation. What is the standard deviation? Standard deviation is always calculated in the mean. If you have seen this bell-shaped curve, I think this is a favorite curve for any statistician, This is a bell-shaped curve, and the middle of it, which is represented by the letter M, is the mean or the average. So, and these green lines on the side, which are dotted lines, are those dotted lines which are describing one standard deviation on either side of the mean, two standard deviations on either side of the mean, and three standard deviations either side of the mean. Simply what happens is that one standard deviation either side of the mean has 68% of the values in your sample, whatever the sample you have used. And two standard deviation has 95% of the values. Three standard deviation has 99% of the values. So standard deviation, as you know from this figure itself, it is like goes along with the mean. People ask me these questions. Then what for median and for mode? So for median, we always use what is known as the interquartile range. It's very difficult to understand. It is nothing but the range between the 25th and 75th percentile. If 50th percentile is your middle value, what is your middle value between 0 and 50th? It is 25. Similarly, 50th and 100, it is 75. So the range between 25 and 75 is called where the middle 50% of your entire values stay. This is called as the interquartile range. I'll repeat again. For mean, the corresponding measure of dispersion is always standard deviation. You would see whenever you see a article, when they report mean, they report standard deviation. So standard deviation is nothing but one standard deviation away from the mean has 68% of the values of your sample. Two standard deviations have 95% of the values, and three standard deviation has 99% of the values, right? Similarly, when you have median, you use interquartile range, which is nothing but the range between 25th and 75th percentile. 25th and 75th. Why 25th and 75th? Because 50th is median, 0 to 50, the middle point is 25, 50 and 100, the middle point is 75. So that is why we use 25th and 75th percentile. Is it clear? Shall we move on? Mean versus median. This is one more question. When I need to have use mean and when we used to use median. Extreme values. When you have extreme values or abnormal values, then you use median because it tries to no average. When you average an extreme value, then it will be a problem for your data. So when you have an extreme value, for example, you are reporting ages of people. Suppose all the ages of people have been 20, 25, 30, this range 20 to 30, then you can use mean. But when you have one or two participants who are out of this coverage area, that like 5 years or 6 years, in that case you should use a median rather than mean to describe your data. Right, there's this again. I'll hand it over to Rizwana. We have a poll 3 now.
Yes, sir. So I think in the YouTube now you have your the code as well as the website. So this is the end of the last poll that we had where everybody is. Okay, so now you will see on the screen the question, like there will be some numbers and you have to click which is appropriate for that, which is an appropriate, what will you use to analyze such a data, which is more appropriate. So I'm still yet to, this question will be there only for 1 minute. So I will wait for a few people to join. And okay. So which measure is appropriate for the following data of age in years? Okay. So the countdown has started. if we are going to give you a data set that has the age of people like this, like 1 years, 34 years, 35 years, 38 years, 40 years, 29 and 32, what will you use? Sir just spoke about using a mean versus median. And so what will you use if the data is like this? What statistical measure will you use? So whatever you feel is appropriate, you can pick. Okay, so if you keep looking on your phone screen, you will know if you have answered it right or wrong. Okay, so just keep looking at your screen. Okay, so nobody chose mode and nobody chose no idea. A few people chose me and few people, most of them have chosen median, sir. So I'm going to hand it over back to you, and you can start sharing your screen.
Okay, so let's go ahead. So once you have described the data, you also, why you're doing a study, anybody is doing a study because you want to do something in a small group, because you can't afford to do in the entire group or the entire world. You can't do a study, and then you want to infer something about a population level. Population level, I'm speaking about all the people in that group. For example, you're doing a study for even for a COVID vaccine, you're doing it in a sample, and then you want to see whether it will be effective for the entire population. What will be the effect of it on a population level if you really want to prove it. So that this type of statistics is called as a inferential statistics. So that is the next level of statistics which we are going to discuss today. But you should also remember that if you infer from a sample, there are always possible errors because you're not including everybody. So there is always possibility of errors. So how to really reduce the error, or what is the level of error which we think can be permissible? So this takes us to a new level of things, the type 1 and the type 2 error. You also call it as alpha and beta error. If you're like really fascinated with Greek alphabets, then it is also called an alpha error and a beta error. It's a very simple way of analyzing something. For example, if this is a simple way of understanding it, a man can usually, at least until today, science has not proven that man can become pregnant. If somebody says man has become is pregnant, that means it is a positivity, but it is a false positive error. It's positive, but it is a false positive error. It's not a true positive. So this is called as a type 1 error. The type 2 error is something as somebody is like a woman who is visibly pregnant, but you do some tests and say you're not pregnant. So what you have said is that you have given a negative test to that person. But what you have done is falsely you have labeled the person negative. So it's called a false negative test or a type 2 test, type 2 error. So I'll again repeat, when you do an inference from a sample to the population, you can commit two types of errors. One is false positive error. That is actually, I can also share one more picture. So reality, what example is? So I'll try to explain with this example. Suppose you're trying to study an association between two variables. Okay, in reality, which nobody knows, there is an association, and you have correctly identified there is an association. Wonderful, no problem at all. In reality, there is no association between these two variables, and you have also correctly concluded that there is no association between these two variables. Not at all a problem. The problem arises when actually you say there is an association, but actually there is no association. The universal truth or the reality is that there is no association. But you have, from your study, you said there is association. So what you do actually is that you commit a positive, you have said it is positive association, but it is a false positive association. This is called as a type 1 error. There can be situations when you say there is no association between these two variables, but as such reality, there is an association. When you commit this, you have said there is a negative association, but this is a false negative association. So this is called as a type 2 error or a false negative association. Of these two, which is a major error? If you think it is type 1, because you're going to do something based on a false association. For example, you will say in reality, for example, coaxin is not working, and this is an hypothetical example, don't quote me anywhere, okay? So coaxin is not working, and you say coaxin is working based on your study, and you start giving coaxin to people, and what happens? People may think with a may not cover the people, and they may get COVID again. So the false positive or the type 1 error is going to be by far most important error, and it can be the effects of it can be really difficult for us to handle. So of the two, if you have to choose one error, then people choose only type 1 error. It's not that you should omit type 2 error, okay? But if you have to prioritize between these two, then you do type 1 error. So do you all understand what is type 1 or the false positive error and false negative error? Do you want me to repeat? Any comments on chat box?
As of now, sir, I'll just check the YouTube as well if there's any comments. If there are any questions, you can please feel free to type in the chat, Zoom as well as YouTube. Any question at the moment, please. If you want sir to clarify anything, please do type it in the.
Sure, we'll move to the next one then, maybe.
Sir, can you repeat once again? Yeah, please repeat. Yeah.
Sure. So I'll repeat it. No problem. See, there is one thing called as a universal truth. Okay. For example, we'll take about example of this covaxin alone. Okay. In reality, covaxin works.
Yes.
And your study also has concluded covaxin works on COVID. No problem, because you have agreed with what is actually the truth. In reality, covaxin doesn't work. And you have also concluded covaxin doesn't work. No problem, because you have agreed with what is actually the universal truth. But sometimes what happens is actually covaxin doesn't work. Based on your sample, you conclude that covaxin works. So what you have done is, in reality it doesn't work. You have claimed that it works. So it is a positive result, but it is not a true positive result. It is a false positive result. It actually doesn't work, but you have committed it works. So this is called as a false positive error or the type 1 error. Sometimes what happens is, coaxin actually works in reality or the universal truth, and you conclude that coaxin doesn't work. So what happens is that you have committed you have said that result is negative, but it is not a true negative. In reality, actually coaxin works. So you have committed a false negative error or the type 2 error. Of these type 1 and type 2 error, if I have to choose one, I will choose type 1, because if I commit that coaxin works as in reality doesn't work, you're going to give people coaxin with that hope that everybody will be protected from COVID, but actually will not. So you're going to commit a grave error there. So if I have to choose between two, I will always choose a type 1 error. And that is how it takes through the next concept which we are going to go through, which is called the p-value. Again, I think Computers like...
You can give a hard push. So there's one more question that people are asking.
Sure.
Isn't type 2 equally important? I mean, though you are saying type 1 is a grave error, isn't type 2 equally important?
See, type 2 is important, but the problem is you can give a leverage, because on type 2, what you're going to do is you're not going to make any decisions out of it. Even though it actually works, covaxin works, you have concluded it is not, you're not going to create any harm to people because of that. So compared to type 2, type 1 is most important error. So that is why we consider type 1 for any of our studies. I think my computer is now like really locked. I need to like stop share and then maybe...
Sure, sir.
Sorry about this. Not expected. Okay. Right. Let me share again. Okay, so this is a favorite of everybody. Like, what is this p-value? Everybody says, what is this p-value? P-value is nothing but the probability value. What probability value? Probability of what? Probability of the type 1 or the alpha error or the false positive error. If you can't remember 1, alpha, everything, you just remember it as false positive error. Probability of false positive error is called as p-value. So p-value reflects the probability of type 1 error or the false positive error. If you can remember this, that is more than enough for you. It becomes important as we infer on population from a sample. We don't want to commit a false positive error and make decisions on whatever our conclusion is. Normally, there is no specific rule that 5% or p less than 0.05 is only statistically significant. It is a general universal accepted rule that p less than like 0.05 is statistically significant. It means that your type 1 error is less than 5% or your probability of this type 1 error is less than 5%. So that is what is reflected by this p less than 0.05. But there is no harm if you want to keep p lesser than 5% also. People have kept it at 1%, less than 1%, 0.5% or even 0.1%. Only thing is you have to determine your p value or your alpha error, allowable false positive error, before you do the study. You cannot do it after you do the study when you are analyzing it. So that is most important. I'll repeat. False positive error is the key error or the most important error we should be worried about. So p-value reflects nothing but the probability of this false positive error. So whenever you're doing a test, in a statistical test, you conclude on p-value. The conclusion, why you need to do a statistical test is also that you're trying to infer from a sample to a population. So your sample, you have a value, you want to know whether this is like it is actually possible, it is because of error or it is not because of error. You are trying to infer to the population. So when you infer to the population, yes, this is likely to be the population level value of this data also. Not population level conclusion. For example, you are studying about two variable association. For example, you are studying about glaucoma and diabetes, and you get a p less than 0.05. Then you are very sure that there is a universal association. It's not just on your sample. There is a universal association between diabetes and glaucoma, but the false positive error is less than 5%. So that is how we conclude based on p-value. Any questions on p-value? Because this is one concept people do not understand that easily. I'm trying to explain it as simple as possible, but if you have questions, I'm happy to repeat it. Any questions?
No questions.
No questions? So I'll move on, but if you have a question, we can really come back to it, because this is one thing people always ask me, okay? Right. Right, this is something which I really explained. So you are giving a new drug for glaucoma to reduce intraocular pressure. Pre-medicine mean is about 28 millimeters of mercury. That the intraocular pressure post-medicine is about 20. P-value is less than 0.05. That means yes, there is an association between this glaucoma, this new medicine, and reduction in intraocular pressure. Right? Okay. It's time for poll 4. So this is another concept. So we'll again do another poll just to understand whether people are like really understood the concept of p-value and stuff. Over to you, Rizwana. I'm stop
Yes.
sharing.
Yes, sir. I'm just. So this is what the previous one was compared to. Okay, so you will all see this question on your screen if you are on Zoom. Otherwise, please look at your mobile phone with the menti.com and the code that is there in the YouTube chat box, and click whatever you think is the right statement for this particular result. So this is a study that says that males had significantly higher mean cylinder power minus 0.56 diopters than females, and then they have given a p-value which is less than 0.001. So read the statements given below. So based on whatever is your understanding of the whole p-value concept, you could just tick that option. So we start to see people selecting options. So everybody, please feel free to participate.
I'll answer one more question I think I saw in chat now. Isn't type 2 error dangerous? Okay. This is another, I think it keeps cropping up again. So what I try to say is that if you have a choice between type 1 and type 2, which one we can choose? That is a type 2, because it is, you're talking about disease screening. I'm talking about association of variables. It is a bit different. But what I'm saying is, if I need to take some decisions based on something, what error is more important as a decision maker? I think type 1 error. It doesn't mean that we are just neglecting type 2 error completely. At an inferential statistic level, if I have to choose one of these errors, I'm voting on type 1 error. That is what we are doing, because it is at a population level. We do not want false positive conclusions, which is very important, rather than false negative error. So that is the reason. It doesn't mean that beta error or type 2 error is not at all important, or things like that. Now, that is not the way it functions. It is important to consider type 2 error, but if you have to take one choice between the two to conclude on something, then I would always conclude on the vote which has been traditionally is for the type 1 error. It's not me, it's everybody. So it has always been type 1 or alpha or false positive error, whichever way you want to call it.
Yeah. So one another example that we commonly use in optometry and ophthalmology is this retinoblastoma thing, sir. Like, I think that's why people are asking, like, when you are screening for life-threatening diseases, then is it like like a false negative, like when the person actually has the problem and then you say there is no disease, then aren't you missing a life-threatening disease? I think that's where people are coming from in terms of screening for life-threatening issues. So I think, as you said, it also depends upon the question, research question that you have, if it is all about making a decision or it is about diagnosing something that's life threatening. But even in that case, if you're making a false positive, like somebody doesn't have the disease and you say that you have the disease, then you are subjecting them to all sorts of unnecessary stress and anxiety. So I think it's only about sort of balancing. What would you say, sir?
See, when it comes to a screening of a disease or a diagnosis of disease, the thing is very different. Okay, we're not talking about it now, but when you do it, we have to balance between false positive and false negative results, because once you try to reduce your false negativity, your false positivity will increase. Once you have a reduce your false positivity, then your false negativity will increase depending on whatever this the test is. So we are not going there, but what I'm saying to say is we need to achieve a balance, and there are ways to achieve balance when you're doing a diagnosis. That is where you use what is known as a receptor operating curve or the ROC curve. I'm not going there. I don't want to scare people away with some really fantasy names in statistics, but you have methods to do it. Okay, so let's move forward. I'm not going to take a lot of time now. So next one is the 95% confidence interval. One is that we said about the association, whether it is in a sample, what is the association which is in the population level, whether it is whether there is an alpha error possible or not, or a false positive error possible or not between these association. But you also need to have some things like a population level value. You are measuring, for example, intraocular pressure in your sample value, but what you want is a population level value. Can I infer something about the population value? That is what is 95% confidence interval. So what is there is that 95% confidence interval always gives an interval which is on either side of the mean or the proportion, whatever you are describing. First thing is that it gives either side of the mean, not one side. So, and what is 95% confidence interval is that this particular interval captures the population level value of that particular variable. For example, if you're talking about intraocular pressure, if I give a confidence interval, that confidence interval will capture the population level intraocular pressure. But we are only confident 95%, not that 5%. 5% can still be, chances there that it will be out of that particular interval. Is it clear? I'll give you an example maybe. Right. This is an example with blood glucose. Suppose my sample blood glucose mean, I'm talking about average, is about 120 milligrams per dl, and my 95% confidence interval is 100 to 140. What I'm trying to conclude is the sample blood glucose is 120 milligrams per dl and the population blood glucose lies somewhere between 100 and 140 milligrams per dl, and we are 95% confidence about it. Okay. If you want, I can repeat it, but what I'm trying to say is p-value, just say whether there is an association or not, whether there's a possibility of false positivity. But if you want to know a value of that particular variable for a population level, then you have to use 95% confidence interval. So whenever you're reporting any thing in your statistics, you have to report the test statistic, whichever it is, a T statistic or a P statistic, whatever you're doing that with a p-value with 95% confidence interval also. Right? Do you want me to repeat confidence interval?
Yes, sir. Please repeat once more.
Okay. Right. what we try to do is that in a sample we have concluded blood glucose is 120 milligrams per deciliter. But that is not our aim. We want to conclude something on the population, okay, based on our sample. But what happens is that you cannot be very accurate on the population because you have not tested everybody. So we are giving what is known as a 95% confidence interval. So 95% confidence interval, suppose for this particular blood glucose example turns out to be 140, then what it means is that my sample blood glucose is 120. But the population level glucose is somewhere between 100 and 140. But how much confident I am? I'm only 95% confident. 5% there's still a chance that this particular interval, that is 100 and 140, does not capture the population level blood glucose. So that is 95% confidence interval. Am I clear now? Anyway, we can revisit it once more if you have a question later, right? Okay.
Yeah, it's clear.
Again, my computer again. I don't know if I get stuck in some slide. It's not. It's like not moving. It's like it doesn't want to move, I believe. Only thing is I have to just go into the computer and change me. I have to stop share and again start. Sorry about this. It's like I don't know why it's behaving so.
So any sorts of questions that you have, people both on Zoom and YouTube, please put in the chat box because we will take in questions. Even when it comes to anything related to statistics in optometry, ophthalmology, any papers that you have read, anything that's really not clear. So sir is only covering like the bare minimum basics. Of course, in 45 minutes and 1 hour, nobody can teach full statistics. So
I'm still stuck with something. Wait 1 minute. My Zoom is. My cursor is missing. Sorry.
oh. So as sir is trying to figure that out. So coming back to this question that you all have answered, we will discuss about the answer as well once we move to the next question, which is very closely related to the p-value, statistical significance, and clinical significance. We will clarify which answer is the one that is expected. Okay, so don't worry about that.
Okay.
Yes, sir.
So the next important thing, sorry. So it's little blurred. Okay. I also didn't realize that when you do and when I did a slide, it was not so blurred. Sorry about this. So what determines a statistical test? How can we conceptualize it? Your research question, your outcome, and your exposure only determines your choice of statistical test. We talked about categorical and continuous variable. If your outcome is categorical or continuous, it also determines the type of statistical test you will use. And use a specific formula, you use a test result. Let's not get into the degree of freedom. It is not at all important at your level. Please don't worry about degrees of freedom at this point. Then we will do the reference table, but usually we don't need a reference table here because all your statistical software directly gives you a type 1 error and then you compare a p-value. So based on this, what I want to convey is that what determines your statistical test is nothing but your variable and your research question. Okay, so that is what determines your statistical test. Another question people ask is also about parametric test and non-parametric test. When to use a parametric test, what is non-parametric test? For this particular thing, I'm not teaching about what is parameter, what is non-parametric test, we're not going there. But as a reference, as a rule of thumb, I'm going to tell you something which is very easy. If you have a sample size more than 30 or mean describes your data very well, you will use a parametric test. If your sample size is less than 30, or your median describes your data very well than a mean, then you go with a non-parametric test. It's just a rule of thumb. There will be exceptions to the rule of thumb, but you need not be aware of it. I am telling you this because there are optometry articles where we come across non-parametric tests which have been used. So that is why I'm just very much telling, when you have used median as a most appropriate measure of central tendency, you have to use a non-parametric test, and the sample size is less than 30. Very small sample sizes, you use non-parametric test. If sample size is more than 30 and meaning for your study more than 30, or a mean is used as the measure of central tendency, you use a parametric test. Okay, this is an example of how you can really find your statistical test which can be done. You need not do tests, but when you're reading an article, you want to see whether they have used an appropriate statistical test. Then this is how we do it, right? I'm not getting into what exactly these tests are, what it does, but this is just a reference guide for you to immediately see whether this is an appropriate statistical test. When you have two types of variables, we just discussed in the beginning of the session, continuous or categorical. When you have a categorical variable, which is you're doing, for example, blood glucose or diabetes, especially when your outcome variable is always categorical. When you have categories, for example, you want to compare association between diabetes and glaucoma, defined as glaucoma, non-glaucoma, and diabetic, not diabetic, both are categories, then you use a chi-square test. If your variable is continuous, and what is your question? You have how many groups you have, depending on groups, 2 or more than 2, and then you have parametric or non-parametric, then you divide it into subtests. If you have 2 groups and you have parametric data, then you use a t-test. Parametric data is nothing but you have a sample more than 30, or mean is the one which describes your data well. But if median describes your data well and you have 2 groups, for example, you are comparing intraocular pressure of people with glaucoma and without glaucoma, kind of, for example, then you have 2 groups and it is a continuous variable, and you have a sample size more than 30, and you have to use a t-test. If your sample size is less than 30, you use a test called Wilcoxon-Moine-Whitney test. You need not remember these names. You can just print this out, or you can just save it somewhere. And then when you have a doubt, you can just go through it. So for people like me, it's where statistics is bread and butter, I remember it because of using it for a longer time. But for all others, you need not. Similarly, if you have more than 2 groups and you have a sample size more than 30, then you use ANOVA. If this not sample size is less than 30, use something called as a Kruskal-Wallis. I'll stop there. Don't go beyond it. It's not for at this stage. Suppose if you have a true dependent variable, that is nothing but you have an outcome and an exposure. You're saying that my exposure is diabetes and outcome is glaucoma, for example. You have a very different dependent variable, and then you want to see what is the risk of glaucoma when somebody has diabetes, kind of. There are 2 ways you can see it. You can just see whether as people are having, as diabetes is as the blood glucose levels are increasing or decreasing, whether intraocular pressure is also increasing or decreasing. You do something called correlation. Or I can also do whether this is just, we'll say whether with diabetes, whether with blood glucose level, intraocular pressure increases or decreases. With 1 milligram increase in blood glucose, what is the increase in intraocular pressure? If I want to know, then you do something called as a regression analysis. With blood glucose, intraocular pressure increases, but I do not know the value of increase, then it is correlation. If I want to know exact value of increase for unit change in some value like a blood glucose, then you use something called regression. Okay, so this I'll stop here. I'm not going to get into whether it's going to be linear, logistic regression and all, but you use regression only when you have a very defined outcome value, outcome variable and a exposure variable, and you want to see whether how much the outcome variable varies with the increase or decrease of the exposure variable. Then you use what is known as a regression. Okay, this is just a ready reckoner for you to really see whether there is a statistical test used as appropriate or not. Okay, again I told you about uh, regression. I'm just going to talk a little bit detail about regression. Whether one biological value varies with another, continuous variable varies with another. When your outcome variable is continuous variable, then you use something called as a linear regression. For example, intraocular pressure, that is a continuous variable. So when you are talking about intraocular pressure as your outcome variable, then it is a linear regression. On outcome, for example, you are going to talk about an outcome like glaucoma or not, or diabetic retinopathy, yes or no kind of, and whether the biological variable increases chance of an outcome which is categorical, then you use logistic regression. When time is involved, when you also have time period over time, whether there is a difference in outcome, then you use different kind of regression called Poisson or Cox. I'll stop there. This is little more for people who do not understand, but if you have a question, we'll be happy to take this and explain it in detail. Okay. Next, I want to talk to you about a hierarchy of evidence. People ask me like, what is this kind of study designs people use? What is the hierarchy of evidence for a practice? The basic thing is also a case report, but it doesn't undermine case reports. You can always write case report. It is considered as a publication, but it is the basic minimum. You talk only about one case or one particular model of a health system or whatever it is. So it's just based on a sample size of one. So that is the basic evidence, which is a case report. It is still valuable because it talks about diversity of some particular cases. Next is a case series. You have series of cases which are reported. You get about 30 cases of a new disease. Then you report them. That is called as a case series. Then you do a descriptive study or a cross-sectional study. Where what you do is you go to the community or into a hospital and you find to see whether you try to measure both your exposure and outcome at the same time. For example, you're going to measure your diabetes status as well as your glaucoma pressure at the same time. That becomes a descriptive study or a cross-sectional study. A case control study where outcome has already happened. People are already having glaucoma. In that, we are taking a history of diabetes and the duration of diabetes, what has been the blood glucose level for the past so many years. This type of study is called case control study. Cohort study. You start with a disease-free population. Nobody is having glaucoma, and then you are trying to define the exposure in terms of diabetes and then follow them up over a period of time and then determine who are all getting glaucoma or not. This type of a study is called cohort study. Then the experimental study, which is the RCT or the randomized control trial, where your exposure is controlled. So far, exposure is not controlled. Diabetes or hypertension is not in somebody's hand to get it. But when you give a drug or you do an intervention, you determine who gets an intervention or not. So that is called as that becomes an experimental study or an RCT. You try to get pooled data or get all the information from all the studies and then summarize it together. It can be done in different countries or different parts of the same country. This becomes systematic reviews and meta-analysis. You start with one case, then a series of case, then you try to determine what are the factors associated with it. So you measure exposure and outcome at the same time. That becomes a cross-sectional study. That is the next level of hierarchy. After that comes, you start with the outcome and then date back to the exposure. You start with people who have glaucoma and then take history of diabetes from them in the past. Then it becomes a case control. You start with the disease-free population. Nobody has glaucoma. then you follow up with them based on, and also measure the exposure on diabetes throughout, and then see who are all getting glaucoma. Then it becomes cohort study. RCT is one where your exposure is not determined externally but by the investigator. I determine who, or the investigator determines who gets into a treatment group or a control group, then it becomes an RCT. Then you have summarizing data and results from several such studies becomes a meta-analysis or systematic review. This is a hierarchy of evidence. So this helps you to understand what is that level of evidence which is coming from a particular study you are reading or a particular article you are reading. Right? Some key takeaway messages before I ask you for any questions you have. Be very clear that whenever you do data, be very clear that you don't keep on analyzing stuff. You have a research question, do analysis only relevant to it, because if you torture your data enough, it starts confessing whatever you want. That is not the way you should do. It's like 9 can also become 6, but if you just reverse it, keep reversing it, pushing it, it can become 6. But that is not the way research is being done. So you should be very careful when you do a data analysis, whenever, or you excessive interpretation of data can also result in such confessions. So be very careful about it. Clinical versus statistical significant. For example, a new weight reduction drug reduces 1 kg of weight of an average among obese individuals. P value is less than 0.05. It is not clinically significant at all. So never go just with the statistical significance. You always think about your clinical significance when you interpret your data. Whenever you read an article, you see, yes, it's statistically significant. Don't immediately start using something. Ask questions whether this value is clinically significant for me, whether it is going to reduce some kind of a disease in that person, if this is going to be the effect of this drug. Then if it is also yes, then it is the way you need to approach an article and then use the results from the article. Biological plausibility. See this example. What's freaking out here is that we have found a correlation between owning cats and being struck by lightning. Is it two variables which are related? You can really do some statistical test to say there is a relationship between some random thing and having banana in the morning and having a glaucoma. You can find correlation, or you can find that these two have an association. But you need to think about what is the biological plausibility. Is these two variables are how they are related to each other, how it can even cause this. So if you're not convinced with it, then please do not use the evidence or do not publish such evidences. Okay, you have one more poll.
Yes, sir. Yes, sir. It's just related to the last poll. So we're going to go with that.
1 minute, then wait. This is about the feedback, right?
Not the feedback, the clinical significance stuff.
Okay, right.
Yes,
Then I'll stop sharing.
Yeah.
You can go ahead.
So I think this is what people have answered for the previous. So for the previous question, when we had asked about this, about the p-value, majority sort of said that, not majority, equal number of people said it is highly statistically significant. And you want to comment anything about that, sir? Like commenting about less than 0.0000.
There is nothing called a highly statistically significant or a lowly statistically significant, very highly statistically significant. No. If you have a cutoff of 0.05, anything p-value less than 0.05 is statistically significant. There is nothing called very highly significant and all. It is like it is significant or not. So don't resort to these terms of highly significant and all. It just means that the alpha error is low, but it doesn't mean it is highly statistically significant and all. Avoid using such terms as such when you read or write or use any such terms in your real this one.
And so the next question is on the screen about clinical significance. Now that you have learned about statistical versus clinical significance, you can then answer. So same thing, go to menti.com and use the code, and then you can type in your answers. Choose your answers. This is the last poll, sir. Once it's done, you could also comment about the answers. So most of them say it's statistically significant but not clinically significant. But there are some people who say that it is highly statistically significant, so it should be clinically significant. So people sort of like believe in this magic of statistics.
So don't believe statistics blindly. That is what is very important in this. I believe that this is not actually, this is like not even a difference as such in an optometry world clinically. So when it is not clinically so significant, don't go with statistical significance as a only mantra for establishing something. It is a guidance, but you should always go with your clinical instinct on the variation. For example, I told you 1 kg weight difference is nothing for a person who is an obese person. So that is nothing. So you need to use your clinical acumen also to see whether that value difference makes sense for you clinically before you conclude. Okay. All right.
Yeah. So as sir said, will you change a prescription because it has changed from 0.50 to 0.56? Like in a standard optometry prescription, this 0.06 is not even within our test cutoff values. So though statistically this paper says that males looks like they have higher amounts of astigmatism, this is not a clinically significant result, and you would not make a statement saying males have higher amounts of astigmatism from this particular study finding. So what sir is trying to sort of reiterate again and again is, don't just get deceived by this p-value numbers. As clinicians, it's important to look at the clinical significance also, and then take the results from any study. Plus, when you want to make statements from your own analysis, then it is equally applicable to all the analysis that you do. And yes, sir, it's over to you to wrap up now. And there's one more question that people ask, I think, about the psychophysical research projects. When there are just 10-15 sample, can we still, and people do ANOVA and things like that? So
see, the thing is that if your outcome variable, you're sure that it is normally distributed at the population level, you can use ANOVA. But if you have the slightest doubt, you should not use ANOVA. You should always go for a non-parametric test. If you have a slightest doubt, it is better to do non-parametric test because you are saved by using non-parametric test. It has been accepted universally. But if your variable is, you're sure that it is normally distributed at a population level, you can do with ANOVA. But what happens is that if you use kind of tests which are meant for only those parametric tests in the situations other than that, then your assumptions are flawed. So that becomes very difficult. For others, please, some of you, it may be like really going above your head. But on the whole, what I want to say is, when you have a smaller sample size, if median is better than mean in describing your data, go with non-parametric test. If mean is describing your data very much than your median, then go with test like ANOVA, which is parametric. Okay. So I just had something to just share once and then stop. Only one picture. Very important at your level is like to just think about is this. if you're talking about clinical significance, looking at statistics, not torturing data, not looking at data being the ultimate gospel truth, meaning that the statistical test results are the gospel truth, you'll be saved. Otherwise, what will happen is you'll end up in something like this random wheel. Today coffee can cause glaucoma in twins, tomorrow daycare can cause depression in rats. Okay, so you do not know what kind of conclusions you can make only if you do go with statistical tests. So be very judicious in using statistical tests. Statistics is a guidance, but you also need to look at your clinical significance. So with this, I think I'll stop, but I'll also hand it over to Rizwana to give some optometry touch to this, maybe, and then also have the final feedback from all of you.
Thank you, sir. So I know that some of these concepts might have definitely gone above the head for people who are listening to statistics for the very first time, but that's very much normal. I mean, if everything has gone inside, then there is something which is abnormal. So don't worry. That's how statistics will sound at the beginning, but as you really get into it, you will definitely start to love it, as I just said at the very beginning. And so we are just going to wrap up this session with just a couple of polls. And so you can just take a look at your like menti.com screen, where I'm just showing up this. So just go to your screen and just type in one key takeaway from today's webinar before we start taking questions. So whatever that you got to learn from the last 1 hour, like whatever it could be, please type in, like, in sentence words or just one phrase, like whatever key takeaway that you had from today's webinar, please do type in the chat box. So this recording is also available on YouTube, so you could also go and listen to it later. And yeah, so people are. The significance of false positive and false negative. Session is so simplified for beginners. Thank you, Dr. MBS. Okay. Okay, so as you're all recalling the key takeaways, okay, so please rate the following statements regarding the webinar. Again, feel free to be very receptive and open, like whatever you think in terms of the last. Of course, as I said, it is not really like in terms of like 45 minutes cannot teach you complete statistics, but whatever we could do, we've done. So I think you could choose the number that best describes your sort of agreement with these statements. And So it's good to see that on an average it's somewhere between 3.5 to 4 point. The range is 3.5 to 4.4 when it comes to people having understood some statistics. So okay, so this is the final slide for the day. If we so each of the concept that Dr. MBS spoke today is worth like one class, okay, and that's how all statistics course is done. And so if we build modules specifically for research methodology in optometry and do it over 8 to 12 weeks, how many of you would be willing to enroll in such a course? So that's what I would like we as a team want to understand, so that we can definitely think about coming up with such a course, because we do see the importance of research methodology. Because whether you like it or not, the truth is this, guys: we are in a world of deep machine learning and artificial intelligence. Next time when you step into the supermarket, just by scanning you, the computer they will know based on your height, weight, your skin color, and your previous purchases what you're likely to choose, and that's what is going to appear right in front of you. So the whole world is sort of customizing things based on the needs of people using large data sets and artificial intelligence models. So whether you like it or not, data related statistics and analysis is going to rule the world. So whether you are in optometry, healthcare, ophthalmology, or you are a general public, it is really important to be scientifically knowledgeable, just to make sure that you're not fooled in the process. Okay, so that is the reason why we thought this whole evidence-based medicine and evidence-based optometry is so very important. Because now that the world evidence-based medicine, evidence-based science is in practice, people are into publishing left, right, and center. But when you read a paper, you should know whether that paper is really applicable to your clinical practice, whether it makes sense to your clinical practice. Just whether looking at that one p value, can you make a whole lot of decision in managing your patient, or in choosing a particular diagnostic test, or whatever it is, or moving the visual acuity from 6.9 to 6.6. Oh, then is this drug really efficacious? Is this treatment really efficacious? So I think when it comes to making those decisions, choosing the treatment of choice, or choosing a screening test, or choosing a diagnostic tool, it is really important to have bare minimum understanding of statistics, whether you like it or not. And so how do we simplify this and this knowledge? Like, having somebody like Dr. MBS, and of course a team of people supporting him in the process. If we build a course curriculum, how many of you will be interested to enroll? The next thing is, many of you are dealing with hundreds and hundreds of patients. Like from OATN, I can vouch on behalf of all our members that primarily as clinicians, we tend to see hundreds and hundreds of patients. These are all, this whole data is the new wealth actually. Now how can you really enter into the scientific world by becoming clinician researchers? Like, how can you publish? Only when you tend to understand the basic crux of statistics, you can analyze your own data and then get into the publishing world. So that is the whole idea of the of conducting this webinar and taking it forward from here. So I now leave the stage to Dr. MBS to take up any questions relevant, or add anything that I have just told.
If you have any questions, anything to be repeated, I can really repeat it. It's not a problem.
They want you to explain odds ratio once more, and yeah.
Odds ratios.
Yes, odds ratio. Once explain odds ratio once more. That's what is one comment on YouTube.
Okay, so odds ratio is usually in an analytical kind of a study design. You use odds ratio, which describes risk of getting a disease. Okay, suppose if your odds ratio, the very common example I'll take is about smoking and lung cancer, and odds ratio is, for example, is 4. It simply means that the risk of getting lung cancer among smokers is 4 times higher than risk of getting lung cancer simple as odds. At the beginner level, if you understand this, it is more than enough. But at an advanced level, we usually teach what is odds and all those things. What is the numerator, denominator kind of. We are not getting there. I'll repeat. If you talk about lung cancer, which is the outcome, and smoking, which is the exposure, and your odds ratio is 4, it simply means that the risk of getting lung cancer among smokers is 4 times higher than the risk of getting lung cancer among non-smokers. Is it clear?
Yes, sir. Thank you. So based on the response now, it looks like almost 82% of our audience is interested to enroll in a formal RM course. Of course, the sample is small, but definitely if you want to add anything, you can add, sir.
Now we also do some customized courses if you're like really interested from an institution level also. This is a course which we are talking about is more for evidence-based practice. Okay, the research methodology course we are talking about is towards evidence-based practice. But if you want to do a statistical course for your own organization or for an institution, we are also happy to do it, but provided we have the time and space and all the stuff which is like really important, but we can really have a conversation. If somebody is interested, please let us know. So we would be happy to take up some courses. We have not done virtually this kind of a complete course. It's also new to us, but we will definitely work it out some way so that it is fruitful for everybody.
Thank you, sir. Thank you so much. So, what I can assure you, both being a student of sir as well as later assisting him with all the research methodology webinars, like how he's doing for optometry, I have assisted him with, handling students of medicine, both PSG and some other Tagore Medical College and stuff like that. So, we've done quite a bit of like basic statistics for people in the medical and healthcare. So, I can definitely assure you that we can simplify statistics to that extent that some of the feedback that we got from these people where they were able to handle their own data, and then some of them even scored like very very high marks in their research methodology courses and statistics. Yeah. So I now ask our Vice President Preeta Ramprasad to give a formal conclusion and vote of thanks to wrap up the session for the day.
Thank you, Dr. Rizwana. So first of all, good evening, everybody. I'd like to thank on behalf of OATN, our speaker for the day, Dr. M.B. Sudarshanam, for delivering this wonderful talk on statistics. Sir, actually, you've laid down the map in front of us and shown us the route as well for the statistical journey. The responsibility now is on us to plan the itinerary and also our journey towards, research and publication. So thank you so much for that wonderful talk, and it was really awesome. Listening to you explain the concepts in a very simple way. So for that aspect, I would like to thank the OATN Scientific and Education Committee for bringing Sir as a speaker for today's OATN webinar. Next, I would like to thank the OATN core executive and educational committees. Last but not the least, I thank all OATN members, the other state optometrists, and also students who are attending both through Zoom and YouTube today. We got a wonderful response in registration. So I'm so glad that you are able to, you're planning to upgrade yourself, and everything is for the better learning aspects. So thank you so much, Dr. Rizwana, and thank you, everybody.
Okay, thank you, and happy weekend, everybody. Thank you, sir.
Thank you.
Thank you.